Today, I'm going to discuss new scientific observations that provide unprecedented insights into the processes behind the formation of a planet. Like most of the discoveries I've discussed on this channel, it should be self-evident to most viewers why it appears to be a highly confirmatory finding for the electric universe theory. But first, I'd like to lay some important background with some discussion of the relationship between the discoveries made possible by stupendous scientific advancements and the impact of said discoveries, or lack thereof, on popular science theory. In science media, we typically see the fields of science and technology merged into a single topic. This makes sense, given that humankind's ability to see and understand physical reality is utterly dependent on technology. And of course, we perceive technological leaps as benchmarks of progress in scientific understanding. Said understanding should only continue to improve hand in hand with technological evolution. Today, thanks to increasingly sophisticated telescopes, astrophysicists are able to peer all the way to the so-called dawn of the universe, viewing objects which they believe formed in the immediate aftermath of the hypothetical Big Bang. However, rather than affirming the validity of the consensus scientific theory, for decades now, ever finer technological data has provided paradigm-shattering discoveries, which should have led to a theoretical revolution in space science, a revolution that has still yet to take place. One of the more powerful examples of this disconnect between discovery and theory came in the early 21st century, as radio telescopes proved the existence of powerful magnetic fields at the cosmological scale. This, of course, was in stark contrast to the expectations of astrophysicists. As longtime viewers of this channel know, I've quoted ad nauseum from the following entry on the official NASA website from the late 1990s. It states, "On the cosmological scale, there is no data to suggest that magnetic fields are present. They certainly are not important in the dynamics of the universe for any reasonable range of field strengths consistent with present observational constraints." The problem of cosmic magnetism became unavoidable early in the 21st century, as radio astronomers began affirming the existence of powerful magnetic fields throughout the cosmos. This fact is acknowledged in a 2011 Universe Today piece, which states, "The mention of cosmic-scale magnetic fields is still likely to be met with an uncomfortable silence in some astronomical circles. And after a bit of foot shuffling and throat clearing, the discussion will be moved on to safer topics. But look, they're out there. They probably do play a role in galaxy evolution, if not galaxy formation, and are certainly a feature of the interstellar medium and the intergalactic medium. Of course, cosmic magnetism is uncomfortable, given that electric currents, which are required for the magnetic fields to exist, are not hypothesized to have any causative role in cosmology. Ironically, it is the technological innovation and hard work of engineers that has illuminated cosmic magnetism, as well as countless other paradigm-shattering space discoveries. And it is engineers who have provided the best evidential basis for understanding the cosmos, including the so-called magnetic universe. And yet, not even the discovery of pervasive cosmic magnetism was sufficient to begin inching astrophysicists toward the experimentally verified arenas of plasma cosmology and the electric universe. This includes the discovery of impossibly well-ordered magnetic fields. This is in total defiance of the standard belief that they were created by the chaotic effects of supernova explosions. Likewise, it was well over half a century ago that Hannes Alfvén, the Nobel Prize-winning electrical engineer and plasma physicist, proposed that stars form by what is called the Bennett pinch, or Z-pinch effect along cosmic filaments, with an electromagnetic scavenging effect of molecular clouds in each current filament. Alfvén wrote of Willard Harrison Bennett's discovery of the Z-pinch in the first half of the 20th century. Important fields of research, e.g. the treatment of the state in interstellar regions, including the formation of stars, are still based on the neglect of Bennett's discovery more than half a century ago. Present-day students in astrophysics hear nothing about it. Decades later, the Herschel Space Observatory imaged a, quote, incredible network of filamentary structures seen in the constellation of the Southern Cross. A 2009 ESA report stated that a dark, cool area such as this would be bustling with activity was unexpected. But the images reveal a surprising amount of turmoil. The interstellar material is condensing into continuous and interconnected filaments, glowing from the light emitted by newborn stars at various stages of development. The conventional explanation for these filaments was the dissipation of some, quote, large-scale turbulence involving exploding stars. However, such explosions would be expected to impose some radial curvature on the filaments, which is simply not seen. And the claim that the filaments are, quote, glowing from the light emitted by newborn stars is simply not tenable, because the filaments glow steadily along their entire length, demonstrating that the light is intrinsic to the filaments, as one expects if the light output is provided by electric current. Moreover, in 2011, even finer images from Herschel provided the conclusive evidence that cosmic-scale electric currents must flow along the filaments. An ESA report at the time states, "The filaments are huge, stretching for tens of light years through space, and Herschel has shown that newly born stars are often found in the densest parts of them. Such filaments in interstellar clouds have been glimpsed before by other infrared satellites, but they have never been seen clearly enough to have their widths measured. Now, Herschel has shown that regardless of the length or density of a filament, the width is always roughly the same." The lead author of a paper on the discovery stated, "This is a very big surprise." The ESA report concluded, "This consistency of the widths demands an explanation." Now, any attempt to explain the filament's constant width by explosions is also untenable. Explosions are required to cause the filaments to vary markedly in brightness and width, depending on the density of the interstellar dust and the perspective from which they are viewed. Of course, constant width is also a feature of electrical discharge, as viscerally demonstrated in the side-by-side images on your screen. On the left is an example of bead lightning, and on the right is a star-forming filament in a stellar nursery. Roughly a decade and a half has passed since the publication of the aforementioned discoveries. However, just as witnessed in the aftermath of the discovery of cosmic magnetism, the popular theory of star formation has remained unaffected in any meaningful way. In other words, space science has failed to advance theoretical understanding commensurate with the remarkable opportunities that stupendous technological advancements have provided. Now, the late physicist Wal Thornhill followed the leads of Alfvén and other pioneers in the plasma sciences, developing his own theories of both star and planet formation. In 2007, Thornhill's paper, Z-pinch morphology in supernovas, was published in the renowned peer-reviewed journal IEEE Transactions on Plasma Science. Unlike plasma cosmologists, Thornhill proposed that the electromagnetic Z-pinch is also a planet-forming mechanism. In another peer-reviewed paper, Thornhill and his co-author, Dr. C.J. Ransom of VimaSat Laboratories, showed that spherules, similar to those seen in the so-called Martian blueberries, are produced by electrical discharge to samples of hematite. As we can see in these remarkable images, the forms also match countless of the planetary and other solid bodies seen throughout the solar system, including many comets, asteroids, and moons. So it was with the awareness of all of these facts that I began the Thunderbolts series Space News from the Electric Universe in 2012. My job was not really to play the role of a theoretical analyst, but rather to compile space science discoveries and data which provide the most relevant testing grounds for the EU theory. I learned a very important lesson along the way, and that is, great insight can be gained into any so-called controversy through the simple compilation of facts which themselves are not controversial. In other words, the real source of a controversy, sometimes at least, is that the decisive facts are simply not widely known. Now let's consider the ever-increasing evidential basis for the cosmic Z-pinch theory of both star and planet formation. Again, we see a terrible discrepancy between remarkable advances in technological data and stagnation in astrophysical theory. Over a decade ago, these images were released of a stellar nursery in the aptly named Snake Nebula. Here we see a number of stars forming along a filament, and the stars themselves break up along a cylinder. This is not expected at all by gravitational theory, which predicts that a center of mass exists toward which all of the surrounding material in the cloud will move and congregate to eventually form a star. What's more, scientists studying the Snake Nebula found that the material needed to be drawn in to form massive stars is far less than gravitational models predict. In 2014, the Harvard-Smithsonian Center for Astrophysics issued a press release, which stated, "Previous theories proposed that high-mass stars form within very massive isolated cores, weighing at least 100 times the mass of the Sun. These new results show that that is not the case. The data also demonstrate that massive stars aren't born alone, but in groups." The team also was surprised to find that these two nebular patches had fragmented into individual star seeds so early in the star formation process. They detected bipolar outflows and other signs of active, ongoing star formation. This dramatic absence of the required material to form stars is not surprising if such objects are formed by the electromagnetic Z-pinch. As Alfvey noted, the electromagnetic force is exponentially greater than gravity and is scalable up to the cosmic magnitude. Likewise, as I've reported many times previously, scientists have also discovered an inexplicable lack of matter in the quote, circumstellar disks about stars to account for the observed planet formation. On the question of how planets form, we must begin with a fundamental acknowledgement. The conventional theories of planet formation by gravitational processes have been falsified, both observationally and experimentally. The proof for this statement is partly affirmed in a science article in the Washington Post several years ago, which states, "According to the traditional story of the origin of the solar system, the planets formed slowly from accretion, as particles in the circumstellar disk clumped together to great pebbles, then slightly larger spheres, on and on until they reached their current size. But when scientists try to recreate this story with computer models, it breaks down. Rather than growing, these incipient planets tend to splinter after reaching pebble size. How could this process result in bodies the size of those in the asteroid belt, let alone whole planets?" Along these lines, consider the discovery just last year, which revealed evidence for planets having already formed in the disk about a YSO, or young stellar object, which is thought to be only thousands of years old. That's right, I said thousands of years. In conventional theory, planet formation has always been believed to take eons of time, up to millions of years. As described in a Universe Today piece, a YSO is only a Class 0 object for about 10,000 years, and a Class 1 object for a few 100,000 years. So finding rings and gaps in the disks around these extremely young stellar objects is a surprising development to say the least. If planets are forming this early in a solar system's life, it challenges our entire understanding of how planets form. It must be noted, as some science journalists have pointed out, it is not yet definitive that the quote, rings and gaps the investigators observed actually represent planetary bodies, rather than some type of instability. However, if planet formation is happening only in a span of thousands of years, it marks both an undeniable falsification of standard theory, and more importantly, the most powerful affirmation possible of Wall Thornhill's theory of planet formation. So with this extensive background having been laid, believe it or not, in my opinion, most of the viewers at home may now actually have a real advantage in understanding the following space science discovery over the actual professional investigators. As described in the February 6, 2025 Phys.org article, dusting for a young star's magnetic fingerprint illuminates planet formation. For the first time, astronomers have succeeded in observing the magnetic field around a young star where planets are thought to be forming. The team was able to use dust to measure the three-dimensional structure fingerprint of the magnetic field. This will help improve our understanding of planet formation. Unfortunately, the usual assumption about planet formation seems to remain unchanged, with magnetism thrown in to offer an assist to the standard vision of dust particles colliding and sticking together. However, the clue to the electromagnetic mechanism behind planet formation can be found in the following statement. The team found that the dust grains aligned with the magnetic field lines. This allowed the team to detect and measure the unseen magnetic field lines, much the same way iron filings can reveal the magnetic field around a magnet. Now, as I mentioned earlier, I am not a theorist, nor do I have scientific credentials. However, neither is necessary for anyone to consider the aforementioned data in light of the theory of planet formation by the electromagnetic Z-pinch. My own non-expert description of the action within the Z-pinch is as follows. Electric currents flow in the Z-pinch along the axis of a plasma column, and in so doing generate a self-induced magnetic field. So-called magnetic field lines constrict as plasma is pinched around the electric current path. In light of this description, how can we now interpret the observed alignment of dust grains with magnetic field lines in the planet-forming region about a star? Let me again repeat Hannes Alfvén's admonition from the previous millennium. Important fields of research, e.g. the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery more than half a century ago. Present-day students in astrophysics hear nothing about it. I'll say again, it's amazing how much clarity can be gained into so-called controversies through the simple recognition of facts, which themselves are not controversial. And this underscores the motivation behind my own continued involvement with the electric universe community, that I might yet see the day when the governing role of electromagnetism in the cosmos is viewed not as controversial, but as self-evident.